This lecture video is on section 2.3 college expenses from your textbook, and in this section we're going to take a look at what input and output variables are. We're going to go from a verbal rule to writing a symbolic relationship. We're also going to look at constructing tables of input and output values, and also how to do some graphs from the input tables. So in our first problem, you are considering taking some courses at your local community college on a part-time basis for the up-and-coming semester. For a student who carries fewer than 12 credits, the full-time minimum, the tuition is $143 for each credit hour taken. You have a limited budget, so you need to calculate the total cost based on the number of Number 1A, describe in words the input variable and the output variable in the college tuition situation. Remember, the inputs are the values that are given or considered first. The outputs are the values that are determined by the given inputs. So, tuition is $143 for each credit hour that you take. And so your total cost depends on how many credits you take. So total cost on number of credits. And whatever something depends on is going to be your input always. So number of credits is the input. And the output variable is going to be your total tuition cost. Okay, choose a letter or symbol to represent the input variable and a letter or symbol to represent the output variable. So a lot of times we use X to be our input variable. You don't have to. You could pick something else if you wanted to. You could pick C for credits or N for number of credits or whatever you want. So I'm going to let it be equal to X, and that's going to be the number of credits. And we also want to choose a letter for our output variable, and I'm going to let T, and that's going to be my total tuition. Would a replacement value of 0 be reasonable for the input values? Remember, the input value is the number of credits. And so I would say yes, that's reasonable, because you don't really have to go to school. Would a replacement value of 15 be reasonable for the input of this? And I would say no. And the reason for that is because it's over the 12 credits. And if you're over 12 credits, then you're a full-time student, and most of the time tuition is different for full-time students than it is for part-time students. Okay, what are reasonable replacement values for the input? Input are your number of credits, and so 0, 1, 2, and all the way up to, let's read that again on the, so it has to be fewer than 12 credits. So once you get to 12 credits, then you would be full-time. So 0 through 11 and only integers, so the counting numbers. What is the tuition bill if you only register for a 3-credit-hour accounting course? So each credit was $143. And if you take 3 credit hours, then you would multiply this by 3. And so if we take 3 times 143, we get 429. So one 3-credit course would cost $429. Use the replacement values you determined in Part E to complete the following table. So we have our input variables of 1 through 11 here. So if you only take one course, it would be $143. If you take 2 courses, then that would be $286. And whoops, we already did 3, that would be $429. And if we took 4, so you can just add the 143 to that, 572, and then add 143, and we get 715. And 858. 1001. 1144. 1287. 1430. And 1573. And so again, you can just take 143 plus 140, and then add on 143, then add on 143, and after you do that, plus 143 equals plus 143 equals a couple of times in your calculator, then if you notice, I just kept on hitting the equals button because the calculator sort of remembers what you did last, and it'll just keep on adding that same number on. So you might be able to do that to get this table filled in rather quickly. Write a rule in words called a verbal rule that describes how to calculate the total tuition for a student carrying fewer than 11 credits. And so the way that you would calculate that is you multiply the number of credits by 143. What is the change in the tuition bill as the number of credit hours increases from 2 to 3? And so it goes up by $143. Is the change in tuition in the tuition bill the same amount for each unit increase in credit hours? And the answer there is yes, it is. This next problem, additional college expenses. Other possible college expenses include parking fines, library fines, and food costs. Student whose first class is later in the morning often do not find parking spaces and park illegally. Campus police have no sympathy and readily write tickets. Last semester, your first class began at 11 a.m. And so problem number 2A, the following table shows your cumulative number of parking tickets as the semester progressed and the total in fines you owed the college at that time. Use the given data pairs to determine how you can calculate the total fine given your cumulative number of tickets. Describe the relationship in words and write a verbal rule. So when we had 2 tickets, the total cost was $25. And when we got 3 tickets, it was $37.50. 5 tickets was $62.50, and we need to figure out 8, 10, and 12. We need to in this spot, why don't we describe this relationship in words? So write our verbal rule. And so how do we figure out what's the total cost of each ticket? That's what we need to figure out. And there's two ways that I would do this by looking at this table. So I have the cost of 2 tickets, so you could do 25 divided by 2. The other way that you could do it is you could take the cost for 3 tickets and subtract the cost for 2 tickets, and that would give you the cost of 1 ticket. And so so if you do 37.50 and subtract off 25, then you get $12.50. So each ticket costs $12.50, and so you're going to multiply the number of tickets by $12.50. Now we're going to fill in the rest of this table, and so if I have 8 tickets, that's going to be 8 times 12.5, and that's 100. And then 10 times 12.5 is going to be 125. And then 12 tickets, every 2 tickets is $25, so a difference of 2 tickets, we just can add 25 on there, so that would be 150. Use the verbal rule to complete the table in Part A, so we already did that. Graph the information from the preceding table. Choose the scale for each axis that will enable you to plot all 6 points. Label the horizontal axes to represent the cumulative number of tickets received, and the vertical axes to represent the total in fines owed to the college at that time. So this is going to be our total fines. And they're calling that F. And then along this axis, it's the number of tickets. And so we need to go from 0 to 12, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces here. So we have 13 ticks, we have 12 things, so we're going to let each of those be 1 unit. Okay, and here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ticks along this axis as well. And for the total fines, we need to go from 25 up to, so basically from 0 on up to 150. And so what you do is you take, because you want to figure out how much each tick mark is going to be worth, and so we want to divide 150 by 13. And you get 11.25. So if you make each tick mark be that or something a little bit bigger, then you'll have enough space. So this is the smallest thing we can let each of these tick marks be, so that we can fit everything on our graph. But there's a nice number. So remember, each ticket was $12.50. So I'm going to let each of my tick marks be equal to $12.50. So I'm going to let each tick, you could let each tick mark be worth 15. 12.5 though is going to put all of my data points on right on the tick marks, which is going to be nice. So each of these is going to be worth 12.5, so that means every other is going to be 25. Okay, and then each tick mark down here is worth 1, so that would be 2, 4, 6, 8, 10, and 12, because I'm only marking every other tick mark. And so my first data point was 225. So here's that data point, 225. And then the next one was 3 and 3750. And then the next one is 5 and 6250. And our next one is 8, 100. And 10, 125. And then 12, 150 was the last one. Okay, so when you're graphing things, make sure that you label any points that you plot on your graph. Okay. Number 3, the college library fine for an overdue book is 25 cents per day with a maximum charge of $10 per item. You leave a library book at a friend's house and totally forget about it. The number of days the book is overdue represents the input. What are the possible replacement values? So this is calculating a fine, and so one replacement value could be 0, so that's the very smallest. You can't really have a book overdue a negative number of days, so negative numbers wouldn't be there, and they're going to be whole numbers, so negative or 0 and then 1, and then you could have the book be overdue by 2 days, and then 3 days, and then you could just keep on going up. Determine the total fine or the output for selected values of the input given in the following table. So if the book is 4 days overdue, we're going to be charged 25 cents each day until we get up to $10, and then that's the biggest fine we'll ever have for one particular book. So 4 days at 25 cents a day, that would be $1. And then 8 days, $2. And then 16 days, that'd be $4. And then 20 days would be $5. And you could be calculating these on your calculator too. I'm just thinking about quarters. So if you have 4 quarters, you have $1. If you have 8 quarters, you have $2. And if you have 16 quarters, you have $4, and so on. But again, you could be doing 0.2 times all of these numbers in your calculator as well. 28 would be $7, 40 would be $10, and then 56 would also be $10. Once you get up to $10, then that's your maximum charge. Write a verbal rule describing the arithmetic relationship between the input variable and the output variable. And so this is multiply, let's see, what does this say? Write a verbal rule that describes the arithmetic relationship between the input variable and the output variable. So multiply the input variable number of days overdue by 0.25. Now we want to graph the information in the table on this graph. And so again, The input variable always goes on the horizontal axis down here, and the input variable is the number of days overdue. And that's going to go from 0 up to 56. And so there's a total of 56 units there, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tick marks to do it in. And so you want to take 56 and divide by 15. And so that would be, so something almost, so 4 or bigger we need to use. And what are we go? And we're going up by 4s here. So each tick mark is going to be 4. And so what you do, what I like to do is take the spread, which is 56, and then divide by the number of ticks. And so that would be, in this case, 56 divided by 15, and we got about 3.7. And then you pick some number bigger than that that works really well with your data. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tick marks. And this is our total fine. And that needs to go between 0 and 10. And so we have 11 tick marks. We only need to go up to 10, so each tick mark can be worth 1. And then along the bottom, each of these is going to be worth 4. And so every 2 will be 8. Okay, so we have a data point 4, 1. And then we have the data point 8, 2. And then the next one is 16, 4. And then the next one is 25. And the next one after that is 28, 7. And then the next one is 40, 10. And after that, was it 56, 10? Yep. Okay, so there's a graph of our data, and we should make sure that we're labeling all of these as well. So this was 4, 1, and this was 8, 2, 16, 4, and that's 25. And then we have 28, 7, and 40, 10, and then 56, 10. And our last problem here, at the beginning of the semester you buy a cafeteria meal ticket worth $150. The daily lunch special costs $4 in the college cafeteria. Fill in the following table. Use the number of lunch specials you purchased as the input variable. So here are a number of lunch specials that we purchased, and we want the remaining balance on our meal ticket. So if we haven't purchased any meals yet, then we'd still have the full $150. If we had purchased 10 meal tickets and they're $4 each, then that would be 40, and so we would have used $40 of our 150, and so that would be $110. If we had purchased 20 tickets, then that would be 20 times 4, which would be 80. And so we would need to take 150 minus 80, which gives us 70. And then here, that would be 150 minus 120, which would be 30. And then here, it would be 150 minus, and 4 times 35 is 140. And so you'd only have $10 left then. Write a verbal rule that describes the relationship between the input variable and the number of lunch specials and the output variable remaining, which is the remaining balance. So what we'd have to do is first we have to subtract, well, first we need to multiply, figure out how much we've used, and so that's taking the number of meal tickets and multiplying it by the cost of each meal, $4. So multiply number of lunch specials oops, that's supposed to be and. And we're going to subtract it from 150. What are possible replacement values for the input variable? Explain. So 0, 1, 2, 3, and we can keep on going. And we're not going to be able to keep on going forever, though. So after 35 meal tickets, we were down to $10. And with only $10 left, I can buy 2 more meals that will be covered in full. And after that, then I would only have $2 left. So we can buy a total of 37. You can't buy the 38th because then you'll be above the 100 and you won't have any money left. You won't have enough to buy that 38th ticket. So now we want to graph this information. And so the input variable is the number of lunch specials. That's going to go on the horizontal axis, and we need to go from 0 to 35. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tick marks to do it. So 35 divided by 15 gives us 2.3. And what did we go up by? So maybe we could do 5 would be good. Or you could do 2.5 if you wanted. And we kind of want to have the data spread out, so I have 15 tick marks. So yeah, why don't we do the 2.5? That'll spread it out nicer. So it'd be 5, 10, 15, 20, 25, 30, and 35. And then the remaining balance is going to be on our y-axis, or the vertical axis, and that goes from 0 up to 150. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 tick marks there. And so when you do that division, you get 8.8. And our values over there going up by nice increments of 10 or so. So I'm going to use 10 for each tick mark. Okay, so now let's start plotting our points. So we have the point 0, 150. And we have the point 10, 110. And we have the point 20, 70. And we have the point 30, 30. And we have the point 35, 10. Okay, and that is it for this lecture video. If you have any questions, let me know. Thanks.